Hi, I'm Frédéric Desbiens. Hey, you! Yes, you! Can you build an impressive SDV embedded application targeting microcontrollers using ThreadX and other Eclipse technologies? Can you master Eclipse ThreadX and even go beyond? If you answered yes to one of those questions, or even both, you must tackle the Eclipse ThreadX challenge for the SDV 2024 hackathon. And so what is the challenge exactly? First, well, to participate, you need hardware. So I brought with me a number of nifty boards like this one. So those boards come with a built-in OLED display, 2.4 gigahertz Wi-Fi network, LED lights, temperature and humidity sensors, a motor, audio support. There's even a headphone jack over there, accelerometer, geomagnetic sensor, etc. So, it's a fully featured board, chock full of things that you can use to build an exciting project for the hackathon. And in terms of developer tools, you won't need to install a complicated SDK or anything really onerous. In fact, you can use Linux, macOS, or Windows. All you need is an appropriate C compiler, and typically the GNU ARM embedded toolchain works for most targets. And then you need CMake, Ninja, and that's it. Since ThreadX has no third-party dependencies, you will just clone my repo for the challenge and be ready to go with a ready-made application that, well, currently does nothing. So it's up to you to make it do something, all right? So now, there are two specific phases to this challenge, and I will explain you what I mean by that. So the phase one of the challenge is really to get acquainted with the board and ThreadX itself. So you need to leverage the board's built-in sensors and peripherals, whatever they be. You're not, it's your choice to leverage just some or all of them. It's really up to you. And really develop a fun little application and sending over data over REST APIs or MQTT or both. Okay, so there are built-in clients for HTTP and MQTT in NetX Duo. So that's the network stack for ThreadX. And it's been pre-configured for you to connect over Wi-Fi, so you can get started right away. So what you need to do there is figure out how to access and use the sensors and the other peripherals, and study the ThreadX documentation to implement the appropriate networking calls for whatever you have in mind. If you tackle this challenge successfully, then the fun begins. Phase two of the challenge really is about going beyond ThreadX by integrating it with other SDV projects. The first option would be, for example, to port the Eclipse Zeno, specifically Zeno Pico, or Eclipse U protocol to run on the top of ThreadX. So I'm trying to make you work for free. Right? Option two would be to leverage other server-side platforms. So for example, you could build something for the car factory of the future by deploying the Eclipse 4DAC Forte runtime on the top of ThreadX. 4DAC Forte is an environment that you use to build programmable logic controllers and or PLCs. And PLCs are used in factories to control robots. So maybe you can cobble together an exciting thing around ThreadX and 4DAC Forte. And that would be cool. Then you could tackle a device management project. So for example, manage your boards in your team and update their firmware with Eclipse Hono and Eclipse Hogbit. And finally, you could build a digital twin solution by creating digital twins for your boards with the Eclipse Ditto project. So I'm a bit knowledgeable about all of those projects, but not deeply. So it will be up to you, of course, to figure out things. But every one of those projects has extensive documentations. And of course, maybe you will find help online, who knows. Anyway, all of this to say is that the possibilities are limitless, and really it's about you to figure out where you want to go with this. So the starter application in terms of code is really, really simple in the sense that there's tons of files in the repos, but most of them, you won't touch them. And so if we look at this a bit more closely, you will see that in the MX chip AZ3166 app folder, that's literally the main folder for the application. Most of the code you will work on will be there or in subfolders. Then there's a lib repository where you have configuration files or straight code for some of the libraries giving you access to the board sensors and peripherals. Okay, so for example, you will see the STM32Cube-F4, which is the proper hardware abstraction layer for the microcontroller on the board. And you will have WeSaid SDK, which brings Wi-Fi support for the built-in networking chip. And then you will see, if you go under shared lib, there are a few things over there. So I pre-configured a JSON parser, the JSMN library. And then NetX Duo and ThreadX are incorporated as Git submodules, so you don't need to deal with them. Everything is wired up to compile, to deploy on the board, and of course, this helps you focusing on the application itself. So there are two main files to look around to get started. So one is cloudconfig.h. This is where you will put your username and password for the Wi-Fi to connect to it. And then there's the main.c file, which is the entry point for the application. So study that, study the other files maybe in the neighborhood, and figure out where you want to bring this. So I hope you will find this challenge interesting. I hope you will tackle it. And I will be around, of course, trying to answer your questions. In any case, after the hackathon, if you want to stay in touch, you can reach me at threadx-info@eclipse.org. Thank you.